Hi everyone, this is Jayashree, Assistant Professor, Department of IoT. So today we start a new topic in the subject control system engineering, right? So this subject is meant for electronics and communication students, second year, fourth semester students. We start with unit number 2, that is control system modeling. In control system modeling, we begin with the topic time response analysis. Okay, right. So, what is time response? So, here response is nothing but the how the system is behaving for a particular input. Okay, so that is response. Response is output of the system. We call it as a response, right? So, time response means how the system behaves when time is varying at the beginning of 0th hour, how the system behaves at the when the time is 1 hour, at it second hour, third hour, how the system is behaving, that thing we are going to study. Previously, in the first topic, we have already discussed about the block diagram reduction. The how to that is a representing a system using a block diagram. How to reduce the block diagram. Then the flow of signal flow graph we have studied, and we derived a transfer function for all the systems. That is block diagram reduction, a signal flow graph, for everything. We have derived the transfer function. Okay, right. The same way here also in this unit, we are going to discuss about the transfer function, but with various inputs. For example, what happens if a step input is given? There are different types of signals: step signal, ramp signals, impulse signals, parabolic signals. That is input given to a system may be varying based on the input, how the system behaves, how the output will be. That thing we are going to discuss, right? So, time response of a system is defined as the output of the system when when to an input, which is the function of time. So in block diagram representation and signal flow graphs, we studied how to obtain transfer function of a physical systems. We have also seen how to combine individual transfer functions to get single transfer function using block diagram reduction technique and signal flow graphs. We shall now study how this responds to different inputs. That is, we'll now take a closer look at the response characteristics of the control systems. So, time response is nothing but that is output of the system, how the output of system will be responding based on various inputs. Right. Next, we'll discuss upon different types of inputs. First one is impulse input. From the name itself, easily understood that the input is impulse. That is, at the 0th hour, there is an input. The signal appears at 0 the time, but when the time is increasing, that is before 0th hour and after 0th hour, the signal vanishes. That type of inputs we call it as impulse input. Okay. See the graph. The signal appears when t is equal to 0. Okay. And after that and before that, there is no signal. This type of input signal we call it as impulse input. Okay. So impulse represents a sudden change in input. That is, the area under the curve is 1. A unit impulse has magnitude 1 and t equals 0. At t equals 0, the unit impulse is the value is 1. Right. So R of t is input signal. R of t equals impulse signals we are represented by del of t. Del of t equals 1 for unit impulse at time t equals 0. When time t is not equal to 0, the value vanishes. There is no impulse. Right. So this is the equation of impulse input. If you take Laplace transform, so Laplace transform of R of t equals 1. That is R of s, we will get R of s, the value is 1. Impulse inputs are used to derive a mathematical model of a system. Okay. Throughout this unit, discuss upon how the system behaves for unit step input and impulse input. Okay, right. Next, we discuss upon second input, step input. Okay, step input represents a constant command such as a position. Okay, it's like a step. The magnitude of input signal is constant at the value a. Right. So an example is elevator. The input given to an elevator is an example. Second one is that is a temperature of an air conditioner. Okay, if you set a temperature, that remains fixed. Okay, throughout the night, if you set a temperature in air conditioner, that temperature remains fixed throughout. So that is step input. The equation is R of t equals A when t is not equals 0. R of t equals 0 when t equals 0. Right. So this is the equation. If we take Laplace transform, R of s equals A divided by S. If it is an unit step, then R of s equals 1 by S. So this is a graph response for impulse step input. The magnitude of A, that is value, is remaining constant. Okay. So that's all about this hour. We'll discuss upon another types of signals in the next subsequent classes. Thank you. Thanks for watching.